Yeah. Hello students. Welcome to PNM Tuition's online classes. So in the last class we have seen what is scattering of light. So in this video we are going to understand some applications of scattering of light. So here some effects of scattering of sunlight by the Earth's atmosphere are, what are they? We have 6 applications. So let us see these 6 applications. We have many applications, but in the for 10th class syllabus, what is that? 6 applications are given in the textbook. So let us understand one by one. What is the first application? Red color of sun at sunrise and sunset is first one, and the second one is white color of the sky at noon time. At noon time, how the sky color? What is the sky color? White color. So next one, blue color of the sky is also one of the applications of scattering of light. And next, black color of the sky in the absence of atmosphere, white color of the clouds, and use of red light for the danger signals. Yeah. So before entering into this these applications, as just I want to tell you one thing. As a point of this last application, red color is used as a what is a danger signals. As you know, the moment when we say red color is having what is that? Most wavelength. How much? Approximately 8000 angstroms, right or not? Yeah, we have seen in the previous video. Now if you see now, white color of the sky at noon, here also white color of clouds. White color, white color is a mixture of all colors, right? So white color is a mixture of all colors. That means what? Here when white color of the sky is appearing as a white color, when we are seeing as a white color sky, that means what? No scattering is taking place. No scattering is taking place. Whereas coming to here also, white color of clouds also. When we are seeing clouds as a white color, that means what? No scattering of light. So white color, whenever you see, what is that? No scattering of light. So that is the reason they are appearing as a what is that? White in color, sky and clouds. So let's understand now red color of sun at sunrise and sunset. Sunrise and sunset, how a sun appears to us red in color, right or not? So why red? Why they are red in color? As I said already. So in the previous video only we have seen what we have seen. Red scatters least, violet scatters most because of the wavelength, right or not? Now here at the time of sunrise and sunset, light from the sun has to travel long distance, right or not? So since the blue light of shorter wavelength is scattered more, much of it's lost, okay, while the red light of longer wavelength is scattered least, very little. So it is not much lost. Red color is not lost much, blue color is lost much because of the what is that? More scattering. And we are comparing here blue and red only. So here we are going to see now blue color and red color only. So why? Because blue color, see here other colors also scatters most, but here with respect to blue we'll understand why sun is appearing as a red in colors during sunrise and sunset. So blue light is almost absent in sunlight reaching to observer. Only who will be there in the light which is reaching to observer, who is there on the Earth's atmosphere, who is the observer, which color is reaching? Red color only. Why blue is not reaching? Because of the more scattering. Okay, so that is the reason during sunrise and sunset how the sun appears red in color. So this is what about the red in color first. So why? Because simply you can also say that why sun appears red in color during the sunrise and sunset, it's a rising and it's a setting, because of the only red color is reaching to our eye. Why red color only reaching to our eye? Because other colors are scattering more because of the less wavelength. Red scatters least. That is the reason red only reaching to our eye. That is the reason it appears as a red in color during sunrise and sunset. Yeah. Now Now white color of the sky at noon, as you know. So at noon, where is the sun? What is the position of sun? At noon, sun is directly above our head, right or not? So sun is directly above our head. So we get light rays directly from the sun without scattering much. Without scattering much, and they will travel what is the shortest distance. So without much scattering of any particular color. So there won't be any scattering of particular color during noon time. That is the reason. What is that? Hence the sky is seen as a, what is that? Which color? White color. So similar to this, white color of clouds also we can understand. So what is that? Where are the clouds? Clouds are near to the, what is that? Earth's surface. Near to the Earth's surface, they contain dust particles, and what are they? Aggregate of, what is that? Water molecules of size. Water molecule size will be, what is that? Bigger than the wavelength of the light. So what is the size of the water molecules in the clouds? The size of the water molecules is bigger than the wavelength of the light. So because of that reason, what happens? No, there won't be much scattering of all the colors. Therefore, the dust particles and tiny ice particles present in the clouds scattered all colors of incident white light from the sun to the same extent. That means for the scattering of all the colors of white light, to the same extent only. That is the reason. What is that? What is that? Which color will reach to our eye? Which color? Scatter light and reaching to our eye. Scatter light is reaching to our eye. Which is scatter light? All scattering of light. White colors means what? All colors scatters at the same extent. So that is the reason we'll see clouds also as a white in color. So that is what, fifth application. Similar to this only. Here, what is that? Without scattering, all the colors will reach. Here, they'll scatter to the same extent. All colors scatters to the same extent. That is the reason we will see clouds as a, what is that? Which color? White color. So that is what about the thing. And let us come to this application. What is it? Blue color of sky. As a light travels through the atmosphere, as you know, when light is emitted from the sun, it has to travel through the atmosphere. It gets scattered of different colors, right or not? Yeah, of course, because by the which particles? Air molecules which are present in air. So who is scattered most? The blue light, due to the shortest wavelength, is scattered more as compared to red color. Just now we have seen here also. So blue color, but here the direction matters. The light reaching to our eye is directly from the sun is rich in red color, while the light reaching our eye from all the directions is, what is that? Scattered. Which one? Blue color light. Who is scattered more here? Okay, blue color light scattering more. Okay, therefore the sky in the direction other than the direction of the sun. So the sky in the direction other than the direction of the sun. How the sky appears, master? Blue in color. So that is what about the reason for the blue color of the sky. What about black color of sky? In the absence of atmosphere, of course, if there is no atmosphere, no scattering of light, right or not? So there would have been no atmosphere. If there would have been no atmosphere, there would be no scattering of light. And no scattering of light means what is that? Sky will appear as a black in color. So similarly, when an astronaut goes above the Earth's atmosphere, okay, what is that? How they'll see sky as a black in color. But to an astronaut, for an astronaut, the Earth appears as a, what is that? Blue in color, because who is scattering more? Blue color is scattering more due to its shorter wavelength. So the stars and other heavenly bodies are seen as usual, but without twinkling. So that is what about an astronaut. Okay, yeah. What about an observer? If an observer is there on the moon's surface, as you know, there is no atmosphere on the moon's surface. If there is no atmosphere on the moon's surface, what happens? No scattering. No scattering means what is that? No scattered light on the moon's surface. Hence, to To an observer on the surface of moon, no light reaches to the eyes of the observer except the light reaching directly from the sun. Thus, the sky in the direction other than the direction of the sun, so will appear as a black in color. So that is what a person or observer who is there on the moon's surface. So that is what about the black color of the sky in the absence of the atmosphere. What about use of red light for danger signals? So here, as here we are seeing in the entire discussion of scattering of light, okay, who is scattering least in the visible spectrum? Red. What is the reason? Red color. Red color wavelength is, what is that? Red color wavelength is what is that? Red color wavelength is how much? 8000 angstrom. Because of this more wavelength, what is that? It is scattered least. So since it is scattering least, means what? It can travel through a long distance because of its high wavelength. Because of its high wavelength, it can travel longer distance. Who? Red color. The red light can be seen from the farthest distance in comparison to the light of the other colors having same intensity. Though other colors are having same intensity like red color, but they are not having same wavelength as like red color. So since it is having wavelength is high, 8000 angstroms, that is the reason it can travel long distance. Okay, so that is the reason it can be used as a, what is that? Danger signals. Danger signals. So that signals may be visible from a far distance. Okay, in the fog also it can be seen. So that is the reason red can be used as a, what is that? Danger signals. So these are the applications of scattering of light. So what are they? Red color of sun at sunrise and sunset, white color of sky at noon, blue color of sky, black color of the sky in the absence of atmosphere. Okay, when white color of clouds, use of red color or red light for the danger signal. Yeah, so these are the applications of scattering of light. Yeah, thank you.